solidification time. So the total solidification time is the time which is required for the casting to solidify after pouring. And this particular time, obviously, it depends upon the size and shape of the casting. And there was a scientist whose name was Chvorinov. And Chvorinov, he gave a rule, and he basically derived a formulation that can also be used for the riser. So the solidification time of casting or the solidification time of a riser can be well calculated with the help of this formulation, and it is equal to TTS. TTS equals to total solidification time in minutes, and it is equals to this constant C and this V by A to the power whole power N. So where V is the volume of the casting, A is the surface area of the casting, and N is the exponent usually taken to have a value of 2. So its value lies between 1.5 to 2. And what is this CM? CM is a mold constant, and the value of CM depends upon different conditions of casting in the casting operation, and it also depends upon the mold material properties, physical and thermal properties like specific heat, density, thermal conductivity, and also the thermal properties of the cast metal, and which includes the heat of fusion, specific heat, thermal conductivity, and also the pouring temperature relative to the melting point of the metal. So using this correlation, you can easily calculate the solidification time, and the solidification, if you put the value N here, so this solidification time is proportional to the square of V by A. So if you increase the volume of the casting, this solidification time will also increase, and if you increase the surface area of the casting, this solidification time will decrease. So this is the concept of solidification time, and this particular approach can be used to determine the optimum size of a riser. However, there are different methods. We will discuss all these methods one by one. So if you can see the concept of this solidification time and the design of the riser can be explained or can be understood with the help of this this particular problem which I have taken from the book of Groover. So you see that a cylindrical riser must be designed for a sand casting mold. The casting itself is a rectangular steel plate with a dimension of 7.5 centimeter into 12.5 centimeter into 2 centimeter, and previous observations have indicated that the solidification time for this casting was 1.6 minute, and while designing the riser, you have to fix one of the dimension, that is to be diameter or height. So they have considered that cylinder for the riser will have a diameter to height ratio of 1. So you need to determine the dimension of the riser so that the total solidification time of this riser is 2 minutes. So what we will do, first we will determine the V by A ratio for the plate, and for this we can easily calculate the volume of our casting or your plate. So it comes out to be 187.5 centimeter, and its surface area you can easily calculate all 6 sides, and it is coming out to be 267.5. And you know that this time period initially was 1.6 minute. So the mold constant Cm can be determined from the equation 10.7 and using the value of n equals to 2 in the equation. So from here the Cm value this came out to be 3.26 minute per centimeter square. And now the next step is to design the riser so that its total solidification time is 2 minutes. So we have to ensure that the solidification time of riser should be high in order to eliminate the solidification shrinkage, so that it will continuously supply the molten metal into the die cavity. And using the same value of mold constant, the volume of riser is given by you can see this is the formula pi d square h by 4, and the surface area of this riser, which is cylindrically in shape, you consider that pi dh plus 2 pi d square by 4. And you all know that we have already fixed this thing, d by h ratio of the riser to 1. And if you substitute this d equals to h in this equation, and so you will have this formula, this v equals to pi dq by 4, and area will be 1.5 pi d square. So thus the v by a, it comes out to be d by 6. If you divide these v and a, so we'll have d equal to 1 by 6. And now use this ratio in Chvorinov equation, and from there you put this value TTS equals to 2 equals to cm d by 6 square, and from here by resolving this equation, you calculate the value of d equals to 4.7 centimeter, and hence it was earlier fixed to be d by h equals to 1. So here the h was it came out to be 4.7. So this is the method of designing a riser using this Chvorinov equation of solidification time. For minimizing the shrinkage defects, this time period, solidification time period for riser must exceed the solidification this time period for the main casting. And since the mold condition, why we kept the mold constant to be equal? Because for the molding conditions we were using the same molding condition for riser and casting, therefore their mold constants will be equal. And by designing the riser to have a larger volume to area ratio, the main casting will most likely solidify first, and the effect of the shrinkage will be minimized. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.